bases and salts in text question 4. While diluting an acid, why is it recommended that acid should be added to water and not water to acid? So before diving deep into the answer, we'll just get a gist of what the answer would be, or I'll just give you an idea of what the logic behind the answer is. Okay, so what do you think? See, we are adding acid to water or water to acid. What's different? Like both are the same, right? No, they are not same. See, adding water to acid is way different than adding acid to water. Like they both are totally different, and they both can cause, like one of them can cause much danger, and there is quite risk in doing so. Let's understand why. So, do you know what type of reaction it is, acid plus water? Yes, it's an exothermic reaction. Like when acid and water react with each other, tremendous heat is formed. Okay, so now let's see the first condition. Yeah. So when we add acid to water, we have to add this acid in very dripping way. Okay, like very slowly. And while adding the acid, we have to stir it as well. So when we add acid to water, tremendous heat is formed. Like because it is an exothermic reaction, tremendous heat and energy is formed. But this heat can be absorbed by the water present in the beaker, right? Like if you take a beaker, fill the beaker half with water and then start adding or dripping suppose hydrochloric acid slowly by the dropper and start stirring it as well. What will happen is the beaker will become warm, but this water has the ability to actually take up the heat and absorb the heat, and thus it cannot cause harm. Okay, but if we do the opposite, like if we add water to acid, what happens is this water will boil up and it will just it will just get away into vapor form, and the heat which is formed in this reaction has no way out to get absorbed anywhere, and this can cause harm. Like it can cause the acid to splash on our face, on our clothes, and acid is corrosive, right? And so this corrosive acid, if comes on our face, it can cause severe damage to us. It can be even fatal. And so it is recommended that acid should be added to water and not water to acid. So this was a gist of the answer. Now we'll write the answer pointwise. When the concentrated acid is added to water for preparing a dilute acid, then heat is evolved gradually. So this is the first point. Because it is exothermic reaction, the heat is evolved. But when concentrated, like when acid is added to water, the heat is evolved gradually. So this was the first point. Next. This energy is easily absorbed by the large amount of water to which acid is being added. So as I said, solute is acid, right? And solvent is water. So when we add acid to water or the solute to solvent, what happens is the water has, or the solvent has, the capacity to absorb the heat which is produced. Okay, and this is why we actually stir the acid, because the acid should be spread out equally, and so So the heat which is produced will actually get absorbed equally. So this was the second point. Next. However, if water is added to concentrated acid, then large amount of heat is evolved at once. So this is the difference between acid added to water and water added to acid. See, when acid is added to water, the heat is evolved gradually, like very slowly, in a gradual process. While if water is added to concentrated acid, then a large amount of heat is evolved at once. Above this, we don't have anything to absorb this heat, right? Because the water just gets faded away into vaporized form, and there's nothing else to absorb this heat, because acid do not absorb heat. Okay, this is an important point. Acid don't absorb heat. So there is nothing to take this heat actually within it. Okay, so what happens is this tremendous heat which is formed can actually damage everything and can actually destroy everything. Let's see why and how. This heat changes some of the water to steam explosively, which can splash on the acid on our face or clothes and cause acid burns. So this is how acid can actually destroy us. See, when acid is splashed on our face or on our clothes, it causes burns, and these burns are so severe that they can't be really, or they can't get healed very easily, like it requires quite long medical treatment and so on. And so it is always said, take precautions while handling acids. This is why. Okay, so this was the fourth point. The fourth point is all about how acid is dangerous to us and what will happen when this water splashes. Like when this water, see, water turns into steam, but this turning effect can cause the acid to splash on our face and clothes. So that's dangerous. Okay, next. Even the glass container may break due to this excessive heat. So you might now imagine how big this energy is. Like even 2 to 3 drops of water are capable to actually break the whole glass container in which the acid is kept. And when the container is broken, the acid will just spread everywhere. It will destroy or it will just deteriorate the table. Because acid are corrosive in nature, it's really harmful to play with acids. Okay, so this is why we are always told in our chemistry lab to handle acids in a precaution, to take precaution while handling the acids. So that's all about the question. Thank you.